In this session, I'm going to talk about choice modeling, wherein we are talking about what do we mean by choice modeling, where do we very commonly use, in what kind of analysis we use choice modeling. Then our focus will move on to conjoint analysis surveys, not the rating based conjoint analysis surveys we have looked at earlier. Whereas here, my intention is primarily to look at choice-based conjoint analysis. Ratings-based conjoint analysis, I can look at using hierarchical linear modeling, which we have used earlier. But nowadays, one of the most common kind of conjoint analysis surveys that are happening are the choice-based ones. So we will talk about the choice-based conjoint analysis surveys based on a data set. What is that we look at in terms of the data for that choice-based conjoint analysis? How do I really fit a choice model? So we will introduce a package as well as a function called mlogit, which is nothing but multinomial logistic regression. Right, we have looked at the binary logistic regression, but here we are going to move towards the multinomial logistic regression where we are fitting the choice model. So once we fit it using this, how do I really interpret the model? What are the various conclusions that I can make out of it? And once my choice model comes out, how do I really interpret the results and how do I report the result to my management? So these are the various aspects that are being considered as a part of this session. So just getting in, see, when we are talking about choice modeling, I'm looking at the product choices of the customer. Now I have different kinds of products, right? Probably when I'm talking of my bikes or cars, right? Or why to that extent, I want to talk about a typical soap. There are wide varieties of aspects that are there as a part of the soap, right? Probably I am talking about the size, right? The fragrance, or probably I am talking about the price. So there could be various aspects that are associated with the product, and based on that, when a customer is buying one product, we could really see what aspects of this particular product are being considered. Is it the price that he is giving more weightage to, or is it the fragrance to which he is giving more and more weightage, right? Or is it the size, or a particular ingredient that has gone into the soap? So we don't know. There are because each product is differentiated on different aspects. Now, when a customer has purchased one particular product, it could be because of any one of these or a combination of these features which has made him to purchase that particular product. So, which means I really need to have an understanding of analyzing the various choices that are available to a customer within a category. So within the soaps, the various categories that are available to the customer, and understand how the various features are affecting what product a customer is choosing, right? To what extent size of a soap is affecting what he is purchasing, to what extent the fragrance is affecting. So looking at the customer's buying behavior, I want to really analyze out of the various choices that are available. Sometimes is he only brand conscious? Out of the various features that are available of that particular product, how do I really relate to what kind of features are being really preferred by different sets of customers, so that I can think of designing products more and more from that perspective. Now, this is what we are calling as choice modeling. So, primarily, when I'm doing a choice modeling, I'm trying to look at what features of a particular product is the customer getting more and more attracted to, and how much are they really willing to pay extra for that particular feature. So what is the level of trade-off for that extra feature against the price? How much are they really willing to pay extra for that particular additional feature? Now these are the things we are trying to look at as a part of our choice modeling. And because it's a complicated linkage, we can't use a linear model. I cannot typically take each feature as a variable and fit a linear model to based on each of the features. That's a very preliminary way of analyzing the various features. So the outcome we are observing here is not a number. So I cannot directly fit in a linear model. It's not a number, it's not a rating. We are primarily talking of the combination of features that are influencing his purchase decision. So there are various number of options that are available to the customer, and each option, so there are so many soaps that are available to the customer. Each soap has its own set of attributes, so based on which each customer is making some kind of a choice on the various features that are available. Now our intention is based on the choices that the customer is making, I really want to extract those attributes, those features which are really being desired by the customers. Now this is where the choice based models are coming into picture, where I'm trying to look at what is the relationship that is existing between the various features of the product and the choice that the customer is making. So every time a choice that is being made by the customer, I'm going to look at what particular feature of this particular product has been an influential thing in the decision of the customer to buy this particular product. That's the reason we try to model this kind of choice based scenario through what we call as a multinomial logit model, where I'm talking about a function called mlogit. In R we will be using a function called mlogit, and nowadays it's the most heavily used model in the world of marketing, where based on the choices that are given to the customer, based on the various alternatives that are given to the customer, depending on whatever he has chosen, we try to identify which features are being typically identified by the customer as more and more appropriate to his liking, and whatever the features he is willing to pay that extra price, his trade-off with respect to, he is doing a trade-off with respect to price for that additional features. Now, so in this kind of scenario, we are using a multinomial logic model, and the process I am calling it as a choice-based conjoint analysis. Because see, many a times what happens here is, in some cases, I cannot collect the data on the consumer's product choice. Probably you look at the cars. He keeps inquiring. A customer will keep inquiring in with different dealers on different kinds of car models at different brands. Sometimes it could be a simple casual inquiries, sometimes there could be serious inquiries. So collecting the data on the product choices could be a much difficult thing, because it could be a very long period affair also, especially when we are talking of high value purchases. The time period of inquiries itself could be much longer, so getting the data of all these things at one place could be a very difficult aspect. Now this is where we are talking of a survey method. So all the possible choices, right, all the possible options are being provided to the customers in the form of a survey. And based on that question, probably I'll give, let's say, 3 questions, right? This is one set of features, this is another set of features, this is another set of features. I'll ask him, out of these 3, which one will you choose? So let's say he'll choose this one. Similarly, I'll ask one more question. Out of these 3, which are having these features, which one will you choose? Now he says he'll choose this. Based on, like this, I'll ask him some 10, 20, 30 questions. And all the questions are more like, I'll give a choice, I'll give 3 options, ask him to choose which one he would be more interested in. So based on that, based on whatever he has ticked, I would try to bring out what are his, what is the kind of choice he is going to make, right? Based on the choices he has actually selected, what features or attribute of that product he is more and more interested in. That is what we are doing as a part of this multinomial logic model. So when we are doing this kind of surveys, it is primarily giving a good amount of information to the marketing guys on what basis the customers are going to choose the products. So I am giving a set of questions, right? As I said, the questions are quite pretty simple. When I am saying question 1, I'll give him a set of attributes, features of a product, right? I'll give him a set of features, probably a price also. Out of these 3, I'll ask him to choose which product will he choose. So there will be a price related stuff, there will be a features related stuff. Out of all these things, I'll ask him to choose which one would he be interested. So he will choose this one. Similarly, I'll design another question again with another set of features, another combination of the features. Then I'll ask him to choose. Let's say he has chosen this. So this is how the survey typically goes. So I'm giving him different alternatives. 1, 2, 3 are the alternatives. So I'm having 3 product options in the survey. And within each alternative, I'm giving the same set of attributes, the features of that product. Only the numbers will change, but the headings of the features will be the same. So each attribute occurs at some level. So the headings will be the same, but the values of each of these attributes will be different. So that is how I'm designing all my questions. So I design at least 15, 20, 30 questions and ask the customers to rank to choose 1 out of the 3 in each of the question. So the structure of the question will be the same. Okay, different kinds of alternatives available, and based on the alternatives, I'll ask him to choose 1. And the kind of attributes, the headings will remain the same across. In this question, all the questions headings are same, but the values for these alternatives are going to differ. So which means, let's say if I'm talking of let's say let me take this example itself. Let's say I'm talking about a car that I want to design, right? So one of the features that I'm talking of is number of seats that a customer would prefer, 6 or 7 or 8, right? Or probably I can talk about let's say the engine that a customer would be preferring. Would he prefer a gas engine or electric engine, or let's say a hybrid engine, right? Or probably let's say I'm talking about a price. Would he be interested in 30,000 bucks, 35,000 bucks, or 40,000 bucks? Now like this, I have different kinds of alternatives that are there, right? So I would like to give all these alternatives, some combination of the alternatives. So the question could be structured like, okay, 6 seats, electric engine, priced at 35. Question 2 could be 7 seats, gas engine, priced at 35. Question 3 could be 7 seats, hybrid engine, priced at 40. Now I'll ask him, out of these 3 features, which one would he choose? So, sorry, this is only question 1. In this question 1, this is alternative 1, alternative 2, alternative 3. Out of these 3, he has to choose one of them. So, let's say he has chosen this. Now, similarly, I'll ask a question 2, which is again some subset of all these things, right? Some subset of all these things. Now, based on that, he will choose some other feature. So, that's how I typically go ahead, and based on that I'll try to use the mlogit function to try to understand what is his overall weightage that he is giving to each of the features, how much of importance he is giving to the number of seats, how much of importance he is giving to the type of engine, how much of importance he is giving to the price, and so on. So if there are more and more attributes that are there, right, attributes are the features, so these are the ones. If there are more and more attributes that are coming in, the number of questions I would be asking would be much more. The number of alternatives in each question also could be higher. So if the complexity in terms of the number of features is increasing, my overall question design also becomes more and more complex, because the number of alternatives will increase, number of attributes also will increase. Today, probably, for understanding the various features of the product, choice-based conjoint analysis is one of the best or the heavily used tool in the world of marketing. And we have to understand, earlier I have already talked about the metrics-based or ratings-based conjoint analysis. Now I am talking about choice-based conjoint analysis. The primary difference is in the way the data is collected. There we have taken more and more of ratings for each of the options. Here I am not talking of ratings. I am giving 3 alternatives or 5 alternatives, and I am asking him to choose one. So this is how the questionnaire is being presented to the customer in case of choice-based conjoint analysis. And based on that, I will try to analyze his preferences for each of the product. So sometimes without choice, I can think of the way he has purchased the product. I can think of assessing what he is preferring. But when I am going with the choice based, I am not looking at his purchase, but I am trying to look at what he would be interested in purchasing when he is presented with 3 different kinds of alternatives or 5 different kinds of alternatives. Let's take one data, right? That becomes more and more comfortable for us. So this is the data that I am using. There is a choice data that is present with me. So if you look at the summary of this choice, so you could see there is a respondent ID. So there is 1 to 200, which means there are 200 respondents in this whole data. And questions wise, I have question number 1 to question number 15. So each respondent is asked 15 questions. Remember here, each respondent, 200 respondents are there. They are marked by their ID. Each respondent is asked 15 questions. So that is where the questions are numbered from 1 to 15. Minimum is 1, maximum is 15. Then the alternatives that are being present, 1 is the minimum number of alternatives, 3 is the maximum number of alternatives, which means there are 15 questions, right? In each question there are 3 alternatives, and these 15 questions with 3 alternatives, they are being asked to 200 respondents. So when I am collecting the data, the 15 questions, right? Question 1, alternative 1, question 1, alternative 2, question 1, alternative 3, question 2, alternative 1, question 2, alternative 2, question 2, alternative 3, and so on. Question 15, alternative 1, question 15, alternative 2, question 15, alternative 3. So this is the way the responses of each of the respondent are captured. Now out of these 3, let's say he has chosen this particular option from question 1. So I have a variable called choice, wherein the values are either 0 or 1, which means if he has chosen it, it will be 1, all these two will be zeros. Similarly, here if he has chosen the second option, then this is 1, these two are 0. Similarly, here if he has chosen the first option, this is 1, these two are 0. So this is the way the choice variable is being captured. So overall, now you could see for each respondent there is 45 rows of data, right? Because one question presented with 3 alternatives, and like that I have 15 questions. So overall 45 rows of data is being captured for each respondent, and we have 200 such respondents, so my data size should be 9000 records. Now this is what I could see from dim of this choice. I could see that it is 9000 rows and 9 columns. Now I could see here the seats, right? The choice is for the seats, minimum is 6, maximum is 8. There is a cargo choice. Do I need a 2 feet cargo versus a 3 feet cargo? Then there is a engine choice, right? Electric engine, gas engine and hybrid engine. And there are pricing choices 30, 35, 40. So these are the kind of options that are being presented to the customer, right? Now you could look at just the head to see how the options are being presented. Okay, respondent ID 1. You could see the question 1 came 3 times. Alternatives 1, 2, 3. Right, carpool is probably people who are using this vehicle for carpooling or not. Now the seats. Now you see the 3 questions that are presented to the first 3 alternatives in the first question. Would you prefer a 6-seater with 2 feet cargo, gas engine priced at 35,000 versus 8-seater, 3 feet cargo, hybrid engine priced at 30, or 6-seater, 3 feet cargo, gas engine priced at 30? Out of these 3, which one would you choose? Now this is where the customer has made a choice that he will choose this one. The respondent 1 has made a choice that he will choose this one. So similarly, the question 2 is saying this one. Okay, now it's a different choice. 6-seater, 2 feet, gas at 30. 7-seater, 3 feet, gas at 35. 6-seater, 2 feet cargo, electric at 35. Now out of these 3, which one will you choose? Then the customer said he is ready to choose this one. Now this is where I try to capture the choices of the customer across these 4 sets of attributes. How many seats? Cargo, what is the space of the cargo? Then what is the engine type and what is the price that. So here instead of just 4, I can have even very high number of variables as well. So if the variable numbers is typically increasing, then my alternatives can't be just 3, alternatives should be more, and even the number of questions can't be just 15. So this is what is our first part. I'm looking at the data, I'm looking at the basic checks on the top of it, right? So each profile, now you look at the format. This is one more thing that we have to understand. This is the format in which the response is captured. Each alternative is in a different row, right? Each alternative is in a different row, and which means variables wise, all the variables, 1 column for each variable, and choice is shown as 0 or 1. So this kind of a format is called as a long format, right? This kind of a format where we are putting 3 different alternatives in 3 different rows. So the same question is repeated in 3 rows, alternatives, each of these in different rows, and each alternative is present like this, and one of the 3 alternatives will be given a 1, other 2 will be 0. This kind of a presentation format is called as a long format. Whereas in some cases for the same question, I'll have one question itself, right? So my data would be like this: respondent ID 1, question number 1, right? Then alternatives. Here I'll directly give seat 1, right? I'll directly call it as seat 1, cargo 1, engine 1 and price 1. Then I'll have seat 2, cargo 2, engine 2, price 2. These are all different columns. Seat 3, engine 3, price 3, column 3, cargo 3. I'll give all these, and I'll also have it as choice 1, choice 2, choice 3. If this is the kind of format I am having the data, so which means one question, it's in one full row, not in 3 rows. So the alternatives are present in the form of columns. So if this is the kind of way my data is captured, this is called as a wide format. So I can have my data. These are the two formats that are quite heavily used when we are doing this choice based capturing. But preferable, right? My preference is always for the long format, because the more and more alternatives I am increasing, I just need to add 1 or 2 more rows. So it becomes much easier in terms of analysis if the number of alternatives is increasing also. I don't need to add new variables. I'm just adding few new rows in the data. So long format is my personal preference, but yes, when we get the data, we get the data either in the long format or in the wide format for this conjoint analysis. So each profile, right, is it in its own line here, which means each alternative is in a separate row, and whatever is the choice for that alternative, it is either 0 or 1 there itself. So the column is indicating which question the profile was displayed in, question 1, question 2, and number of profiles for each question. So more and more rows are being added for each question depending on the number of alternatives that are available. So the package, the formatting of it in this is the long format, not the wide format. Sometimes we have the feature in R, we have a function called reshape, where you can do a reformatting to your required, but when you are capturing the data, if you capture it in this format, it's much more easier for understanding and analysis. Now, first thing is do a summary of the data, which we have already checked, right? How many times each level of the attribute appears in the question. It's better that I have some of them as factors, right? It's better that I convert. You could see here, probably let me do a structure of choice to just see which ones are integers and which ones are factors, right? I don't need these things to be integers, but more or less price I want it to be a factor, and even the choice I want it to be a factor. These are the two things, and probably seat also I would prefer to be a factor itself. Choice area, it's 0 or 1, doesn't matter. But seat and price, I want them to be factors. So that's where I'll first say choice dollar seat. Let me make it as a factor. As dot factor choice dollar seat. I'll make it as a factor first of all. Similarly, choice dollar price, let me make it as a factor, as dot factor, I'll use choice dollar price. So based on this, again, if I look at the structure of the choice data frame, yes, all these variables at least are factors, right? Questions hardly matters. Alternatives, I can keep them as it is. So once this is the way that I have, this is the data that I have with me right now, I am ready to perform some kind of modeling on the top of this data. Now I can do a simple head, right? These are very common things that I can very well do. I did a summary of it. right? All of them are more and more, right? Otherwise, let me do a quick summary now where I should get my how many are falling in each of the segment. So 6 cars, there are 3024 preferences. For 7 seats, 2900 preferences, and for 8 seats, 2983 records are there. Similarly, when we talk about the price, there are almost 2998 responses going for a price of 2000, 30, right? Price of 35, there are 2997 responses, and price of 40, there are almost 3000. So now I want to look at computing the choice counts, right? I want to look at choice. So which item has been chosen in how many cases? Let's say based on the choice, right? How many people have chosen 6 cars, 7 cars, 8 cars. This is the presentation part. Presentation part, 6 cars came 3000 times, 3024 times. 7 seats came 2900 times, and 8 seats also came 2983 times. But when I come to the consumer choice, right, he has given once. So wherever he has given once, I really want to find out, right, in how many cases 6 seaters were chosen, in how many cases 7 seaters were chosen, in how many cases 8 seaters were chosen. So which means I am trying to do the counting of choice versus seat. I am also doing choice versus cargo. I am also doing the counting of choice versus the engine type, so that I will get a high level raw count of how many has been chosen at each of the cases. Now to do this kind of counting, right, choices based on seats and all, I'll use this XTAPS formula. XTAPS is doing counting of one variable across the other variable. So cross tab kind of stuff. So I'm using XTAPS. I'm trying to count the choice where the choice is 1 across the seat. So I'm trying to count the choice. So how many ones are there in the choice for each of the seat levels. So the data that I am taking is choice here. Now I could see 6 seaters have been chosen in 1164 questions. Right, out of the 9000 questions, obviously 3000 will be chosen, because 15 questions, one is chosen by each person. So 15 choices and into 200 respondents. So 3000 will be the total number of choices. So out of the 3000 choices, it looks like 6 seaters are preferred in 1164 cases, 7 seaters are preferred in 854 cases, and 8 seaters are preferred in 982 cases. So probably 6 seaters are looking like more and more preferred ones. Then probably I want to see, is there any preference with respect to cargo? I could see 2 feet cargo is preferred in 1300 cases, whereas 3 feet cargo is preferred in 1688 cases. So there is a slightly higher preference among the customers with respect to 3 feet cargo. Then similarly, I can look at the kind of engines that they are preferring, right? So I can give the engine preference. I could see that there's a lot of preference for gas engines, 1444, almost 50% out of 3000. Hybrid is also to some extent, but electric engine is looking much on the lower side. So there is a very less preference for electric engine altogether. And I want to look at it with respect to price as well. So I could see first step by doing this work, yeah, lot of people want 1486 as the price, right? 950, sorry, 30 as the price, 1486 people, which means in the 1486 choices, it was a choice for price 30. For 35 it's close to 950, whereas very few people, only few responses were there where 40 was preferred. Overall you could see there were 3000 questions, 3000 rows where 40 was present, but choice wise it's only 558. So there is a very little choice, there is a little preference of the people going for 40 as the price. So you are initially able to do your choice across all the various features to get a very high level overview of to what extent the customers are preferring each of these different choices. Then once you have this information, we are going more towards the fitment of the model. So when I am using this mlogit, this is coming from mlogit package itself. So I need to install the package. Let me install and load the package mlogit. So I am installing this mlogit package. So this is the most commonly used model for choice modeling purpose. This is the most commonly used package in R, and the concept that we are talking of in this context is the multinomial logit model. Sometimes we also call it as a conditional logit model, right? Either we call it as a multinomial logit model or conditional logit model. So I am trying to load that particular library, right? So it's most basic and commonly used choice model. So I'm first thing is, yeah, this is very important step. This does not accept the data in the current format that I had, right? The format of my current data is there is one separate row for each alternative, and choice wise there are zeros and ones. That's the data that we have captured in Excel. But whatever is it, it has to be transformed into a model called mlogit.data. This is a different kind of data format. So I mean this will convert your data which is present either in a long format, that is where our data is currently in a long format, or in a wide format. Depending only these two data, whatever are they, mlogit.data converts it into a completely different data format, so that format would be given as an input to the mlogit. Mlogit does not directly take a long or a wide data format. So intermediately there is one step called mlogit.data. This data, this kind of a function converts your long or wide format data into an mlogit understandable format, right? So that is where first you have to convert your data that is in the long format to mlogit.data kind of a format, and once you have converted it, then you can very well use it as a part of your mlogit model. So here you have to give a few more additional parameters to this mlogit.data. Apart from the data and whether it is in the long or wide kind of a format, you would also have to specify which are all the variables in your data that are varying. So which means what are all the parameters of your data, which are all the variables that are typically varying. I have to specify all those variables that are changing, and I also need to give my ID. ID is based on which the customer preferences are typically changing. So I have to give that particular input also as a part of this as a part of this mlogit.data. If you just want to see what it gives, let me just quickly do mlogit.data. You could see, you could understand from the help function what are all things that it is expecting. So the column, now you could see I have to first give the data. The data we already have. So let's start giving it, right? Probably from the help file, let's take the help. So mlogit.data, let me save this. So let me say choice underscore mlogit or mlogit data only, let me call it, because it's the data format. Okay, choice underscore mlogit data is the name I am saying. mlogit.data, the first input I have to give is the data. So let me give data is nothing but my choice is the name of the data. Then the input that I have to give is choice. Choice is the variable including indicating the choice made. So I have to say which variable is indicating the choice. So obviously here the variable that I have as a choice is also named as choice only, right? The variable, if you look at this variable, this is your choice variable, which is indicating the choice of the person, choice which the customer has chosen. So data wise I am choosing it as choice because that's the name of my data frame. The choice variable, it's named choice only in this context. These two are very important. Then I have to give the shape as either wide or long. So this is where I can set my shape, which is the data. I have already said the shape, the data is in the long format. So let me give it as long. Then separator, I don't need the right. I can talk about alternate levels. What is this alt dot levels? The names of the alternatives, if null for a wide data frame, they are guessed from the variable name, so we don't need to provide any of these. id.var is very important here. If you look at what it is, the name of the variable that contains the individual index. So I can very well give response id. I'll give id.var is equal to my variable response id. How is it? This is resp.id. So I'll give this as the response id. Right? And what else? So varying, one more variable that I have to talk of, varying the indexes of the variables that are alternative specific. I have to give the indexes of those variables which are alternative specific, right? The alternative specific, so I have to give all those variables which are specific to the alternatives. So I can set my varying is equal to, I have to give those columns which are varying. So I could set, these are the four that are varying. So I will set it at so I can set my varying as column numbers 1, 2, 3, 4, 5, 6, 7, 8 are the columns that are varying here. So I will set it as 5 to 8. So these are the variables that I am simply setting as a part of my model. So at least one of the alternative alt.var or alt.levels has to be filled. Alt.var alt.levels. Alt.var, name of the variable that contains alternative index for a long data frame only, or the name under which alternative index will be stored. So I can give the alternate levels, right? The names of the alternatives. So if we'll give the names of the alternatives. So let me give the alt dot levels. I'll call it as three things: position 1, position 2, position 3. Right? Some such kind of naming I can give. So either I will type it as POS 1. Let me put POS 2, or I could have used paste also. Right? POS 3. Let me give these three alternate levels. These are the three questions. So let me give them as three questions: alternative 1, alternative 2, alternative 3. Let me try now. Okay, I have to give a comma, not a dot here. 5 to 8. Then after that I am putting a comma. Unexpected numeric constant. Where is it? Size equal to choice, shape equal to long, id dot var. Varying I am setting as 5 to 8. Alternative levels I have put them as paste. Where is it missing? Unexpected numeric constant. Oh, position 3 here has to be put in quotes. This has to be a text. Okay. So because of the now I am giving the levels as position 1, position 2, position 3. So now it became an mlogit data. Now probably if I want to see what is there as a part of this choice underscore mlogit data, this is how it got created. You see here, the alternatives got created like this. You could see now the respondents, right? You could see the name as 2995 dot position 3, 2995 dot position 1. So this is the mlogit format. And now you are seeing 200 is the respondent name, 10 is the question number, then these are the alternatives, carpool, yes or no. These are the four variables that are the choices for the individual, and the choice based it has made them as true or false. So there is that kind of a transformation that it is doing within this. So either that is the reason I have to give the alternative. So if there are three alternatives, I have to give some kind of names through all these three alternatives. So here the 1 will become position 1, 2 will become position 2, and so on. Now this is where I'll get started. Right now the help file is no more required. So this is how you can use the help file as well. Now once my mlogit.data is created, now I can use my mlogit function, more or less similar to any other regression models, but I have to use it on my mlogit data object. So that's the only thing. The data now I will consider is not my choice, but I'll consider it as choice underscore mlogit data. So that is the data that I am using as the input. If intercept is needed, I'll not put this 0 plus, but if intercept is not needed, I'll put this 0 plus into my model. So let me create two models here, right? Choice underscore no intercept model, wherein I'll try to take it as mlogit. Now the first thing is the variable that I'm looking at is my choice as the dependent variable. The independent variable, because I am talking of no intercept, I will put it as 0 plus the variables that I am looking at: seat, I am looking at cargo, I am looking at engine, and I am also looking at price. So these are my 4 with 0 plus. 0 plus means intercept will not be considered. And my data is choice underscore mlogit data. So my model is created now. Right, I can very well look at the summary of this particular model. Choice underscore no intercept. So this is giving just like your others. Okay, for position 1, the frequency of alternatives, it's saying 32.7%. For position 2, it is around 33.4, and position 3 it is 33.8. So position wise there is not too much of a difference between the alternatives. Right, it's not the first position, because first alternative is chosen. In some cases, just blindly the customer might take the first alternative. Just to avoid that kind of scenario, we are looking at the frequencies of the alternatives. Okay, almost there's not too much of a difference in the choices, which means customer has really gone through the various alternatives that are available, and based on that evaluation of the alternatives only, they have really gone ahead and checked their choices. That's one thing that we are able to make out here. But much more than that, right, we could see a few more important interpretations from the model. So this is one model. If I am including the intercept, I have a slightly different answer that I am going to get. Right, so this is my choice underscore no intercept. We'll interpret both the models together. So I'll take choice underscore intercept this time. When I'm taking choice underscore intercept, my model is more or less the same, but this time it will not have 0 plus. So only this part I'm going to remove. Alright, so I'm executing this data. I can look at the summary of choice underscore intercept model. So these are the two things that we are looking at. Let's come back to one by one. First, let me come out with the no intercept model. So I'm looking at the coefficients, right? I could see that almost all the coefficients are significant. Right, all the coefficients are significant. So I am looking at the coefficients of the entire population. Now here you could see seat 7 and seat 8 are displayed, which means seat 6 is the base. Seat 6 is the base here. Similarly, cargo 3 feet is displayed, means cargo 2 feet is the base. Similarly, engine gas, engine hybrid is taken, so engine electric is the base. Price 35, price 40 are given, so price 30 is the base. Now, how do I interpret these coefficients? The choice wise, seat 7 is having a negative value, which means customers are giving a negative choice for seat 7 compared to seat 6. So seat 6 is preferred more than the seat 7, and same logic wise seat 8 is also having a lesser value, which means overall if I see, seat 7 is having the least. Seat 7 is 7 seaters are preferred the least. Then comes the 6 seaters. So 6 seaters are very highly preferred because 7 and 8 both of them are having negative coefficients. So probably I could see from this model, the customer is preferring 6 seaters more heavily, right? Then comes the 8 seater. Okay, then looking at the cargo, compared to 6 feet this coefficient is positive, which means the 3 feet cargos are more and more preferred because they are all significant. I can say that the preferences are more significant itself. 3 feet cargo is significant compared to a 2 feet cargo, but very big difference is coming here. So engine gas is having a very high estimate 1.53, whereas hybrid is having 0.71, which means both of them are positive numbers. Gas is having a much bigger number compared to the base electric. So I could see gas is very heavily, the size of this coefficient matters a lot. So gas is very heavily preferred compared to electric. At least hybrid is moderately preferred by the customers. And when it comes to price, also we could see similar kind of a behavior. Compared to 30, 35 is carrying a negative value, means slightly lesser choice. But 40 is looking like a much bigger negative, which means it's more or less a kind of not expected kind of a choice. So customers are not really preferring 40 as a product at all. And overall log likelihood of this model is 2581.6 negative. And we said if I have to compare between the two models, I am more and more looking at the log likelihood value itself. The higher the log likelihood that is coming out, the better would be the model that I am preferring. Now the same thing if I go with the frequencies, let's look at, right, with the integers, with the intercept. If I go with, I see now there are two additional columns, two additional variables that got added. So because position now also is treated as additional variable, position 1 will be taken as a base. I want to see whether the position 2 is in the position 2, is there any difference with respect to position 1? Means putting a question in second position, second alternative or third alternative, is it really impacting the customer's choice? Because generally sometimes the customer may blindly tick the first one or the second one or the third one. So this is where I really want to assess if there is some kind of a preference that the customers are going for, if there is some kind of a difference in which the choice, the position of the alternatives is making an impact in the decision of the customer. But I could see that the p values are greater than 0.05 here, which means the position is really insignificant. In that case, I could very well omit the intercept and go ahead with my model. But all other things still are significant, right? Even when I have made them with intercept as well, the likelihood ratio also is more or less looking the same. So whatever is the model that I am going with, either this one or this one is not preferred here because there is no impact of the position. So I can very well go with the original model itself. Now these are the things. Let me quickly look at, did we cover everything? So estimates list the mean value for each level. So I have to always look at it with respect to the base. With respect to the base, each of the choices, are they really higher or are they lower? Positive values indicate that their preference or choice for those is much higher. The size of the coefficient is very important. So gas engines are being preferred much more higher, and the 40 price is preferred much lesser compared to the base. And the estimates are larger in magnitude. So the more and more is the estimate, then the preference is much higher. Generally, you will find these numbers on a plus or minus plus or minus 2 kind of a scale. So more and more closer to minus 2 indicates a strong negative preference. More and more closer to plus 2, you will indicate a very strong positive preference. Then we are looking at standard error, where we talk about the preciseness of the estimate. So the lesser is the standard error, the most preference it is, which means that is what will get translated into t value and your p value. So if the p value is less than 0.05, you can very well assess that this estimate is a much realistic and reliable kind of an estimate itself. So I should have very less standard error, which should result in very low p values as well, which is what I have got in almost all the alternatives. If I have to really compare the two models, now I have two models with me, right? I can very well go ahead in terms of comparing both the models. So when I have to compare both the models, I can use really LR test. LR test is a function that I can use, which is a likelihood ratio kind of a test, right? Which makes a null hypothesis whether these two models are equal. So null hypothesis says these two models are more or less equal, whereas the alternate hypothesis says no, there is a significant difference between these two models. So the models are choice underscore no int, and I will take choice underscore int. These are the two models I want to check. I could see that the p-value is 0.7122, greater than 0.05. So my decision is in favor of null hypothesis, saying there is not any much of a significant difference between these two models. So there is no point in including intercept as a part of the model. I can very well omit the intercept, and I can very well go ahead with whatever is the non-intercept portion of the model. So that's how I can very well go ahead and report, do the summary and do the kind of reportings, right? LR test I can execute, and in some cases, yeah, there's a different thing that I want to bring in. In some cases, the predictors, here I have taken all the predictors as factors only. Out of these four, I have taken them as factors. But let's say I want to convert something into a numeric. Let's say the price as a variable, right now I have taken it as a factor. But let's say I want to take it as a numeric and I want to do my model. Right, so probably let's say I'll call it as choice underscore no intercept underscore price, where I'm taking price as numeric. So this is where I can again use one more model, the mlogit model, where I'm looking at choice is a dependent variable. 0, I'll take the no intercept model. Seat, same, no change. Cargo, I am not changing. Engine size, engine type I am not changing, but price I'll convert it into numeric. Right now it's a factor. So factor, if I have to convert it into numeric, first convert it into character and then into numeric. So that's where I'll say as dot numeric, as dot character, and whatever is my price. So first the factor will be converted into character and that character will be converted into numeric. So this is where I am first converting it, and based on that I have to provide my data, which is nothing but choice underscore mlogit data. So this is a different model that we are getting, where I would like to look at the, so here price is no more a factor, I have made it as a number. So now when I have looked at the summary, I don't get it as three different prices here. It's coming out as one single price and the estimate is coming out to be negative. So which means as the price is increasing, the choice is decreasing. Price is showing a negative number. So as the price is increasing, the choice is getting decreased, right? The chances of that particular high priced one being chosen is going down. That is what is an indication of a negative value as a part of the price. And I could also see now the log likelihood is 2582. So I really want to see if these two models are really significantly different or not. That is where I can again go with my LR test, right? Choice underscore no int versus choice underscore no int underscore price. Is there any difference between these two models? Still my p-value is greater than 0.05, which says there is really no difference between the two models. Which means irrespective of whether I have chosen the price as a character or a factor versus I have chosen the price as a numeric, there is hardly any kind of a difference. But now when it is actually a numeric, I have a different way to interpret the output that is coming out for me. Now this is where I want to look at price, especially as a numeric, though I am giving the question as a factor when the customer is answering it, but now I want to evaluate it as a number, so that I really want to assess how much is the customer willing to pay extra for a particular feature. That is one more thing we are trying to compute here, which is what we are calling as a willingness to pay. So coefficient reporting we have already talked of, but one more aspect that I can compute here is the willingness to pay. How much is the customer really willing to pay for a particular feature? Right? Now this is where I can very well talk of the coefficient. Now this is the coefficient for cargo 3 feet, and this is the coefficient for the price, right? This is the coefficient for price, this is the coefficient for cargo 3 feet. So basically if I say 0.476 divided by, take only the absolute, 0.173. So when I take this number, it is 2.75. So 2.75, and now if this is in thousands, this 30, 35 are in thousand, I can multiply it by 1000, and now I can say the customer is willing to pay $2,750 extra. So which is as good as saying, if I want to be more and more appropriate, I'll take this number divided by this number. I'll omit the sign. So compared to 2 feet cargo, the customer is willing to pay 2.75 thousand, which is $2,750 compared to a 2 feet. Right? Compared to 2 feet cargo, he is ready to go with a 3 feet cargo, for which he is ready to pay an excess of 2,750 bucks. So I can really make out what is the kind of excess the customers are willing to pay for one extra attribute of this particular product. Probably let me put the same in the other way. So for an engine, gas engine compared to electric engine, right? For a gas engine compared to electric engine, the customers are willing to pay 8,823 bucks. So they are ready to go with the gas engine. They are ready to pay almost 8,823 bucks extra compared to a typical electric engine, all else remaining the same. They don't mind paying an extra of 8,800 bucks. So that is what we are calling as the worth of that particular feature. Or I could say it is that extra price where the customer is really indifferent between the two options, which means, so an electric option available for 30,000 versus a gas option available at 38,823, he is really indifferent. So which means the gas, if it is available for 40,000, he will not prefer this, he will prefer this one. But if the same is available for 35,000, then he may prefer this alternative. That is what is coming out. The price at which the customer is really indifferent between the two options. The same case here you can make the other way. Compared to a 3-seater, compared to a 6-seater, if I have to look at a 7-seater, right, the customer wants a reduction of 3,000 bucks. So if he has to prefer, if you have to make him prefer a 7-seater compared to a 6-seater, there should be a reduction in the price by the extent of almost 3,084 bucks. So by making price as numeric, we can do this kind of the price which he is willing to pay extra, or which he is willing for a reduction in the price if he has to go for that specific feature compared to the base feature. So I can compute it for each and every attribute. And based on that, I can also assess how much the customers are willing to pay for each of these various features. So that's one more output that really comes out of our choice modeling. Another important thing as a part of our analysis of the choice of the customers. So this is what I really wanted to cover as a part of this session. If you have any further queries, you can get back to me by giving me a call on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.